Hi guys, welcome back to our last lesson in the first half of topic 9. Lesson 9.4, we're going to be solving quadratic equations, and we're going to be seeing a lot of square roots today. So we have some new vocab, properties of equality. That's just a fancy phrase for when we use opposites in math to solve an equation. When we are solving for x, we always use opposites. That's all that means. So in example 1, we are going to see x squared in every one of these problems, and our goal is to solve for x. Now let's zoom in on this first question. It says, what are the solutions of the following equations? Now, our first goal always is going to be to isolate x squared. Normally, we isolate just x, but in order to do that, we have to first isolate x squared. And good news for us, it's already isolated. Once x squared is on its own on one side of the equation, here's what we're going to do. We're going to take the square root of it. This little 2 exponent is the inverse of taking the square root. Just like how we do like plus and minus, how those are opposites, a square and a square root are also opposites. And whatever I do to one side, I always do to the other. Now, most of us know that when we take the square root of 49, we know that's one of our perfect squares, which is 7. But it's also a negative 7, positive and negative. With every square root that we take, we are always going to have 2 answers, a positive 7 and a negative 7. And here's how we're going to show that. We call this a plus or minus, and we put the little plus on top, little minus on bottom, and that just shows that we have 2 answers. The answer here could be positive 7 or it could be negative 7. When I plug that number back in for x, both positive 7 and negative 7 squared get me to 49. We will have a plus or minus in every one of our answers. All right, let's go ahead and try this one down here. So we've isolated x squared already. Let's go ahead and take the square root right away of both sides. These guys right here are opposites. They just cancel, and we're left with just x. The square root of 169, we could type that in our calculator if we're not sure, but this is one of our perfect squares. It is 13. Positive 13 is one answer, but negative 13 is another answer. So the final answer, we call that plus or minus 13. All right, let's jump over here. I'll solve another one. All right, let's go ahead. Take the square root right away. Anybody see a problem right here? So 121, I believe, is one of our perfect squares, but we learned in an earlier lesson that we can't take the square root of a negative ever. And that's just because whether I plug in a positive 11 here or a negative 11, we're never going to result in a negative answer. So right away, if we are ever taking the square root of a negative number, we're actually going to stop right here and just say no solution. And again, that's just because we can't take the square root of a negative number ever. We're going to see that again in this next example. So let's go ahead, take the square root on both sides, and right away we see that we are trying to square a negative, and we cannot do that. If that ever happens, we stop immediately and just say no solution. This is the entire basis of lesson 9 for you guys. We are going to take it up a few notches in each of these next examples. We're just going to add in some more numbers, and our goal is still to just try to isolate x squared, and then we take the square root, and we're done. Let's go ahead and try it in example 2. All right, what are the solutions of each equation? Now, here's the only difference in this next problem is that x squared is not by itself. We have the 7 out front that we have to get rid of. How would we normally get rid of that 7? Well, we would divide it out. So we're going to first just start by solving for x squared. We want to get x squared alone. And just with one step, we already did that. Those 7s now cancel out. 112 divided by 7. I'm going to get my calculator out here. 112 divided by 7, we get 16. Now that x squared is isolated, we have to do that first before we can solve for x. But now that we have that, we are ready to take our square root on both sides. The square root of 16, this is another perfect square. That is 4, positive 4. But we know that every answer, anytime we take the square root, we're always going to have 2 answers, a plus and a minus 4. Let's try it again over here. All right, I'm seeing some negatives, and I know that we learned a new rule that if we ever take the square root of a negative, we're going to have no solution. Just because I see negatives right off the bat, though, I can't assume that we're going to be doing that, because look at what's going to happen here. All right, in order to isolate x squared, we have to divide out that negative 3. And when I divide by negative 3, that actually makes all the negatives go away, and now we're in the clear. So negative 24 divided by negative 3 is positive 8, and now we're ready to take the square root. 8 is actually not one of our perfect squares. So we kind of have a few ways that we can write our answer here. Since we can't take a perfect square from 8 right away, really what our answer is right now is plus or minus and then just the square root of 8. Since it's not a perfect square, we can just leave it like that. Except last lesson, we learned how to simplify this further. And here's where 9-3 is going to help us out in this lesson. So the square root of 8 is not a perfect square itself, but we can break it down into a perfect square. 8 is the same thing as 4 times 2, and 4 is one of our perfect squares. Then I can pull that out front, and when I pull a number out, we always take the square root of it. And so now this is 2 on the outside. We took the square root of 4. This 2 stays on the inside, and that right there is the same exact thing as the square root of 8. Those are the same number. This is more simplified. So we're going to go ahead and bring over the x equals. We're still going to have our plus or minus out front, and this is just a better version of the original answer that we had. So both things that are underlined, circled in blue, those are the same numbers, but we always want to try to simplify as far down as we can. So this answer right here is the better answer. Alrighty, let's go ahead and just try one more in example 2. Our goal always is to isolate x squared. In order to do that, we first have to divide out 5. And when we do, we are left with x squared equals 25. All right, take the square root. Boom, boom. We know that 25 is a perfect square. We love when this happens. It's definitely positive 5, but negative 5 would also be an answer here as well. X equals plus or minus 5. All right, let's do this one over here just real quick. I forgot there's one little extra thing we might have to talk about. So our first goal, like always, we got to isolate the x squared. How do I get rid of a fraction? Well, when they're squished together like this, that means they're being multiplied. And I could essentially divide out that negative 1/2. We can absolutely do that, or we could multiply by the reciprocal. I'm going to show you how to do that just as a quick refresher in this example. I'm going to times both sides by the reciprocal of negative 1/2, which is negative 2 over 1. That right there is our inverse operations. Those cancel each other out. We have isolated x squared, and now I just have to simplify this over here. We're going to times the two numbers on top to get a positive 72 over just 1. So 72 is our answer on the right side. All right, let's go ahead and take the square root. Because we have x squared isolated, we could finally take the square root, and 72 is not one of our perfect squares. So for this one, though, it says state what two integers the solution is in between. So if it says something like that, they want us to say what, instead of simplifying like we did in the last example, instead of simplifying here, we actually want to just type this in our calculator and figure out what two whole numbers is the square root of 72 in between. So when I type that in my calculator, there's a few buttons we have to click. We have to do second x squared, and then you'll see the square root symbol pop up. Second x squared, then type in 72, and here is what we get in our calculator. We should be getting approximately 8.485, and that's going to continue to go on for a very long time. So what two whole numbers is this number in between? We would say somewhere between 8 and 9. Those are the two integers, two whole numbers that the square root of 72 fits in between. So again, if you see that phrase here, what two integers is the solution in between? Instead of simplifying the square root, you can just type it in your calculator, find the decimal, and then state the two whole numbers. All right, we're going to take it up one more notch today in example 3. we're still doing the same thing, guys. Our goal is to isolate x squared just like we normally would in any equation. It might even be helpful to just think about the x squared as maybe just one variable right now. It's just one big x. So how would I solve 3x minus 5? Well, you guys know we would use inverse operations to get rid of the 3 and the 5. That's always going to be our first step. All right, I'm going to draw a line down my equal sign since we're getting a little bit more complex now. And we're going to start by plussing 5. When I do, we're still left with 3x squared on the left. These guys cancel. And 22 plus 5, we have 27. All right, last step, we divide by 3. We're left with x squared equals 9. And we're getting good at this last step. Once x squared is isolated, we take a square root on both sides. That allows us to have x alone on the left. The square root of 9, 9 is a perfect square, that is positive 3. But we also are always going to have a negative answer as well. So x can be positive 3 or it can be negative 3. I can always check my answer. I should be able to plug in 3 and negative 3 for x, solve this through, and we should end with 22 every single time. Just a quick way to check your work if you would like. All right, if you're feeling good, go ahead and pause and you can try these next two. Otherwise, I'm going to go through these next two a little bit quicker. All right, first step, we're going to get rid of the minus 19 by doing the opposite. Those 19s are going to cancel. We bring everything down. And here is what we're looking at. Let's go ahead and cross out those 19s. Perfect. All right, last step. That negative 5 is squished up against the x squared, which means they're being multiplied. To get rid of it, we do the opposite. So we divide it out. We're left with x squared on the left. 163 divided by 5. Ooh, we are getting a decimal right here. Let me just double check I did my math right. 144 plus 19. Yep, 163 divided by 5. All right, let's see. So 163 divided by 5. I'm checking it one more time. Yeah, we're definitely getting a decimal here. So there's actually two answers I'm going to accept here. And actually, I lied. There is one answer I'm going to accept. Let's take a look. Let's just leave it how it is right now. So 163 over 5. And then that negative, I'm just going to pull that out front. There is a bit of an issue that it took Miss Farr just a second to see as well. It is difficult. It's really easy to miss is what I mean. A negative right here. We have isolated x squared. And at this point, we are ready to take the square root. But can I take the square root of a negative? We never can. So you know what? Having that decimal pop up on our calculator was actually a good sign. We should be seeing that there was some sort of issue that was going to arise. And here it was, we cannot take square root of a negative. So right away, we stop here and we just say there is no solution. There's no x value that's going to make this equation true. All right, last one for solving equations over here. Let's go ahead and solve. All right, here's where we're at in that first step. Last one, I'm going to divide by 3 to isolate the x squared. We got a nice number this time. That's a really, really good sign. Go ahead and take the square root now, and we are left with x equals plus or minus 8. Okie dokie, guys. So that is the extent to what our equations are going to look like. That's the hardest it's going to get. Now, there is one type of problem, a real-life situation that we're going to look at, and that is using Pythagorean theorem. Here's the thing, though. It's going to look just like these equations. Here's exactly what Pythagorean theorem looks like. A squared plus b squared equals c squared. We'll talk about where those numbers come from in just a second. But really what we're doing is this is just a real life equation that we use in the real world that we can solve in the same ways that we were doing before. So it says that we have a cell phone tower and it has a guy wire support as shown. The height of the tower and the distance from the tower to where the guy wire is secured on the ground, they are the same distance. What is the height of the tower? So looking at our picture here, here is what that was saying. This length right here and this length right here we have labeled x. That means that they are the same distance. Now, these two lines right here that I highlighted, the two that are measured x, they meet at a right angle. We call each of those sides, I'm going to label them L, we call those the legs. And the legs in our equation for Pythagorean theorem, we have a choice. They can be A or B, and what's awesome is that they are the same length, so it really doesn't matter which one goes where. But what we know for sure is that A and B are always the legs of the right triangle where the 90-degree angle meets, and that's exactly what we have to plug in for A and B, the measures of those sides, which for right now is just x. Now, C is a fun character. C is always this diagonal line. The fancy word for it is a hypotenuse, and that is always going to be represented by the letter C. And we can see what that exact length is. That is 200. So that is the number we're going to plug in for C. When we plug everything into Pythagorean theorem, we have to square each leg. So x squared, and we add those together according to Pythagorean theorem. And then we set that equal to our hypotenuse squared. All right, our goal is to just simplify this. On the left-hand side, we have some like terms, x squared and x squared. We can add those together. We don't add the exponents. The exponent will actually stay exactly the same, and the variable. We only add the numbers out front. So we get 2x squared when we combine those. On the right-hand side, 200 squared, let's go ahead and punch that in our calculator. 200 squared, looks like that is 40,000. All right, we are looking at a problem very similar to what we did in example 2. Our goal, if we're going to find x, we first have to isolate x squared. And in order to do that, we have to divide out that 2. When we do that, x squared is left alone on the left-hand side, which is exactly what we want. And 40,000 divided by 2, we get 20,000. All right, we've isolated x squared. Let's go ahead, take the square root. Is 20,000 one of our perfect squares? I'm going to test it in my calculator. Let's try to take the square root of 20,000, and we're getting a decimal. Interesting. What that means is that it's not a perfect square. Let's try to simplify it. Let's see if there is a perfect square that goes into 20,000. Now, I believe that 100 is one of our most iconic perfect squares, and it should definitely go into 20,000. Yeah, so 100 times 200, when I multiply those, and you know what, I should be putting my square roots in here as well, we can break 20,000 down into 100 times 200. This is a perfect square, so we can pull that out by taking the square root of it. I'm going to bring my work down here a little bit. The square root of 100 is 10. So 10 is now on the outside, and 200 we're still going to leave on the inside. We're always going to have that plus or minus out front, and right now that is what x equals. Can I keep going, though? Is there another perfect square that we can break down 200 into? Yes, there is. We can break this down into 100 again, 100 times 2. So we can take out another perfect square. We take out another 10, and we times it by any number that's already out there. And now we have 20 out front. Oh, sorry. Nope, we want to not add them. We want to multiply them. Now we have 100 out front. 10 times 10 is 100. This 2 we can't pull out, so it just stays on the inside. And I believe this, guys, is our most simplified answer. All right, one little thing to think about is since we are talking about now a real-life situation, we're talking about the lengths of a triangle, we probably are not going to use our negative answer. Now, it is still technically an answer to the equation, but once we start talking about geometry, we are a lot of times with distance only going to use our positive answer. So just kind of keep that in mind going forward.